This is just kind of extra information that makes things go sometimes a little bit faster, but it's not necessary. So here it is. Can I get everybody to pay attention? Some of you are still writing, and that's awesome, but I don't want you to miss this. You know how you're allowed to multiply any equation you want by whatever number you want, as long as you do it on both sides and you're consistent about it? You can do the same thing with division. And that's useful sometimes for us because if we've got a whole bunch of stuff that divides by the same number, look at this first equation. I got 18, 12, and 24. There's a pretty big number that divides 18, 12, and 24. What is that number? 6 goes in all of them. I am allowed to actually divide everything in this equation by 6. I'm going to get a new equation, but it's going to basically be the same equation. I still got a couple people not paying attention who really, really need to see this, okay? If I divided all of these things by 6, what would I get? What's negative 18 divided by 6? Negative 3. And what's negative 12 divided by 6? Negative 2. And what's 24 divided by 6? 4. Okay. This equation is the same as this equation. Tell me, what number could I divide 6 and 3 and 18 all by? Those can all be divided by 3. If I divided all those things by 3, wouldn't I end up getting this exact thing over here? Yes? Now, I'm going to tell you right now that these two equations, or these two systems of equations, have the same solution. They are the same system of equations. That's why I told you to stop, because some of you are like working furiously trying to finish the second one. If you've already solved the first one, you don't need to solve the second one because you're going to get the same solution. If you had your choice to solve one of these or the other, which one would you rather solve? I'd rather do the one with the smaller numbers, right? So you don't have to do this, but if you want, and if you're working through an assignment, I'm looking at number 5 right now this is going to be on your assignment for today. I'm looking at this bottom equation here. Look at those. There's a 4 and a 4 and a 24. What's a number that I can divide all of those things by? I can divide them all by 4. And it would be a significantly easier equation, wouldn't it? In fact, I wouldn't even divide them all by 4. I'd divide them all by negative 4 and turn this into just 1x plus 1y equals 6. That's a simple equation. Then I'd probably divide this top one. All those divide by something too. They all divide by 2. So we could really, pretty easily make a lot of these things a lot simpler so that we're dealing with smaller numbers. And that just makes the algebra easier to deal with. All right, for those who weren't here, let me give you the crash course in how to solve these systems. So these are systems that are set up to solve by elimination. I'm going to put a 1 in front of that y. And the big idea is I want to eliminate my x's or my y's. I'm going to add these things together. And I'm hoping that when I add them together that the x's eliminate. But these x's would not eliminate. If I had negative 3x plus 2x, that gets me negative 1x. We want them to cancel each other out. So the idea is I'm going to multiply one of my equations by some number. And I'm allowed to do this as long as I'm consistent. I do the whole equation. For those who did the second one, what did you multiply the second equation by? Multiplied it by 2. And the reason we chose that is because think about what would happen to this 1y. If you multiply it by 2, what would it become? It would become a 2y. And what's going to happen with this 2y and this negative 2y? They're going to cancel. They're going to eliminate. That's what we want. We want them to eliminate. So I'm going to rewrite my equations. The top one didn't change. Negative 3x minus 2y equals 4. And the bottom one, everything in the equation gets multiplied by 2. 2 times 2x is 4x. 2 times 1y is 2y. 2 times negative 6 is negative 12. And then I want to put a line underneath them and put a plus out in front. I'm going to add them together. And when I do this, I'm expecting either the x's or the y's to eliminate. And this time it's the y's. They cross out. They're gone. Negative 3x plus 4x is just 1x, isn't it? 1x equals 4 plus negative 12 is negative 8. And there, we've solved for x. X is negative 8. So the idea of elimination is you change your equations so that either your x's or your y's are going to cancel each other out. And then when you add them, you get a nice simple equation that only has x or only has y. You solve that, you got x. To find y, just like before, we just need to go back to one of those original equations. Doesn't matter which one. I kind of like the looks of the top one. Actually, the bottom one doesn't have as many negatives, so I'm going to go with the bottom one. The bottom equation was 2x plus 1y equals -6. I left the x out, though, because I know what x is. X is -8. And then we just have to solve that equation. We're going to get -16 plus y equals -6. And one more step of algebra. Let's do plus 16 on both sides. And we'll have our y value. Y equals 10. So final answer, -8, 10. And if you did the first equation, or the first system correctly, you should have gotten that same answer, because these two systems are equivalent. All right, any questions on that one? Those who did the assignment, this is going to kind of be a little bit of a